All right, welcome back, guys. We're going to be doing some of these examples. There's 5 examples on here, and I'm really hoping that my iPad doesn't die before we finish this. So let's cross our fingers. Okay, so starting with our first example, Mg plus O2 turned into magnesium oxide. Start by drawing our line and adding up our atoms on both sides. So magnesium, we have 1 on the left, 1 on the right, and the oxygen, 2 on the left, 1 on the right. That's not balanced. So first thing we need to do is add a coefficient on the right-hand side. So we're going to just go ahead and write in a 2 here and see how that changes our numbers. Oops. There we go. 2, that was a 1. So our magnesium is now at 2. Oxygen's now at 2 as well. So our oxygen is even, but now our magnesium is off. And that's okay. That's a very normal thing that happens when you're balancing equations. So don't get stressed about it. We just have to keep balancing it. All right? So now we have 2 magnesium and 1 on the left. So we're just going to go ahead and write a 2 there. And that will become a 2. Magnesium is balanced. Oxygen is balanced. We're good. This is a balanced chemical equation. And again, we can either leave this O2 blank or you can write in the 1. Either is fine. All right, next one. So we have N2O5 and HNO3. Remember to write it in the same order. So it's a good way to say organized. On the left-hand side, we have 2 nitrogens. We have 6 oxygens, right? Because we have 5 here and 1 there. So we add those up. And 2 hydrogens. On the right side, we have 1 nitrogen, 3 oxygen, and 1 hydrogen. Now, you might see the solution already, because if we look at it, the left-hand side has double the amount of everything on the right-hand side. So if we just simply do this, this coefficient 2 is going to distribute out amongst all 3 elements. So 2 times 1, 2 times 1, that's 2. And then we have 3 oxygen atoms in this molecule, but now we have 2 molecules, so that'll lead us to 6. Right, because we take this thing and we make another one. It's kind of if we just looked at it conceptually, now we have 2 of these guys floating around. All right, so this is now balanced. I'll just draw in the 1s. Check, check, check. Moving on. All right, so we got calcium oxide bonding or reacting with water to form calcium hydroxide. So let's see, we have 1 calcium, 2 oxygens, and 2 hydrogens. On the right side, we have 1 calcium, and this is where we need to pause for a second. You see how we have this parentheses and a subscript after the parentheses? That is telling us that we have to take that subscript and distribute it out to each element. Okay, so that is telling us that we have 2 oxygens and 2 hydrogens. Okay, because we have to take 2 to each one. We have a hydroxide and we have 2 of them. And maybe they're bonded to the calcium, like something like that. So if we look at this, our checklist, we're even, right? We have 1 calcium, 2 oxygens, 2 hydrogens. That is a balanced chemical equation. We didn't have to do anything for that one. All right, we got 2 more. All right, so first one, we have aluminum. There's 1 aluminum. Copper, we have 1. And then chlorine, 2. On the product side, 1 aluminum, 1 copper, 3 chlorine. So the first thing we see is the chlorine is not even. And we'll start with the smaller number, right? Because we can't get rid of atoms, law of conservation of matter. So first thing I'm going to do is just, well, there's a few things we could do. If I add a 2 here, let's see what happens. So this will change the copper into 2, right? Because we're distributing it out. And 2 chlorines times 2, that'll make 4. Okay, so we're still not even yet. And this is where we kind of have to find the, like, this is just like math. We need to find the least common, or the lowest common, say lowest common denominator. Basically, what number do 2 and 3 share? Right, so let's redo this, and instead of a 2, let's put a 3. So we'll cross these off again. So 3, now we have 3 copper, and 3 times 2, right? We take that, times it by 2 chlorines, now we have 6. So that is something we can work with more easily with this problem, because now that kind of takes care of our 3 dilemma on the product side. Because now we can take a 2 here, and we can distribute that out to where we have 2 aluminum and 6 chlorine. So our chlorines are good, our aluminums and copper are off. But if we look at the rest of the problem, that's okay, because aluminum and copper both are isolated on the 2 sides that we need to change them, right? So we have 3 here and 1 there. It's no bueno. So we're going to go ahead and put a coefficient there. So copper's even now, chlorine's even. And we'll do the same thing with aluminum. So we're 1 to 2. We need that to become a 2. And that's even now. So that's entirely balanced. So what I mean by when I say the lowest common denominator, I'm talking about the 6 that we got from chlorine, right? We started with a 2 and a 3. Those don't go into each other very well, and we can't use fractions or mixed numbers. We can only use whole numbers. So the first number that 2 and 3 have in common, the lowest common denominator, is 6. So then you have to figure out how to get to 6 on both sides. On the reactant side, it was by taking 3, timesing it by 2. On the product side, it was the opposite. Add a 2 coefficient and times it by that 3 subscript. Okay, so this is our balanced chemical equation. All right, last one. There's a lot of stuff going on in this one. So we have hydrochloric acid. We'll just start from the top. And so when we're counting, we have 1 here, and then we have 2 there for a total of 3. Chlorine, we have 1. Calcium, we also have 1. And oxygen, be careful with that subscript. That distributes out, we have 2. On the right-hand side, start with hydrogen. Let's go in the same order. 2. Chlorine, we have 2. Calcium, we have 1. And oxygen, we have 1. So this is a lot of off things here, right? There's a lot of things that aren't balanced. So this is where we can we have to take a survey of the chemical equation and see how should we start. All right, we kind of have to do some investigating for this game. Okay, so I see right now, like as I'm thinking through this, we have chlorine 2 here and 1 here. What would happen if I added 2 to this one? That would change hydrogen from 3 to 4 and chlorine from 1 to 2. Okay, so maybe next I go to hydrogen here. So now it's 4 to 2, and I add a 2. So that distributes out. We now recount the hydrogens. We have 4 on the product side and 2 oxygens here. Now, I was thinking I was going to have to do more work just because of all of the off numbers, but this is an example of where things kind of fall nicely into place. And you'll kind of see that from time to time. It's kind of like a jigsaw. Things go together like really perfectly sometimes. And sometimes they don't. Sometimes it's a little messy. And really for these, they kind of take a lot of time and practice. So if you get frustrated or if you get impatient with them, just know it's not always going to go perfect. You just have to keep trying. A lot of trial and error. I will be around for Zoom meetings, and if you have any questions, let me know. Have a good day.